I have one function in this video. I want to find a power series representation for the function written below and determine the interval of convergence. So we already discussed the strategy in the previous problem. So I want to make the given function looks like 1 divided by 1 minus x, and then this one, the reason I picked this problem, trust me, this one takes a little bit more effort to do the factoring. So now here is the path. Look at the function 1 divided by 1 minus x. Look at what we have. On top we have x squared, the bottom we have x to the fourth. So to make the top equals to 1, so what we have to take out is I have to take out an x squared. All right, so now the top is 1. What about the bottom? The bottom we have 1 minus x. All right, so that will be a 1, but in the constant value is 1, but our constant value in this function is a 16. So the next thing that I would like to take out is I take out a 16. So we only have x to the fourth divided by 16, and then you add 1 to it, right? So that is what we have after one factor. So since we have 1 minus x, so what we will have to do next is we still keep the x squared divided by 16 outside, and then inside the fraction we have 1 on top, and then the bottom I want to do a 1 minus. How do you force to put a minus in there? Easy. All you have to do is you put another minus in here, and then the fourth power I plan to do x to the fourth divided by 2 to the fourth power, because 2 to the fourth power is 16, and you're right, that's why that number has to be a 16. If that number is a 15, then we will have a huge trouble. So that is equals to x squared divided by 16, and then inside the parenthesis we have 1 divided by 1 minus. So the minus, the x and the 2, we can keep that. The fourth, we can bring the 4 outside, right? And then here, so if you bring the 4 outside, that means we have a little problem with the minus, because the 4 doesn't belong to the minus. So we have to make a small modification in here. So what I'm going to do now is I will just bring the 4 outside like this, and then don't let the 4 affect the minus, and then I will keep a square bracket in there. Okay, so overall, we have the power series, n goes from 0 to infinity, x squared divided by 16, and then the 1 minus x, what is the base? The base is negative x divided by 2 raised to the fourth power, right? Do you see that? Look at the yellow highlight. So you have an x, so the x goes into the base, and what is our x? Our x is this piece. Okay, so the base is, we have of something big raised to the nth power. The base, we put that inside the square bracket, that will be x divided by 2, and then we raise that to the fourth power. So the geometric series is convergent. So let's write this down. The geometric series is converged when the absolute value of the common ratio is less than 1. So in our case, the absolute value of the common ratio is negative x divided by 2 raised to the fourth power less than 1. And then, since there is an absolute value, we can just take away the negative. So x divided by 2 raised to the fourth in absolute value is less than 1. And then that is between negative 1 and 1, right? X divided by 2 raised to the fourth, and then less than 1. And then all you have to get rid of the fourth power, all you have to do is, still remember that, you take the fourth root, right? On each side. So you have negative 1, and then this is a 1, and then this is a x divided by 2, and then you multiply each side by 2, you have negative 2 less than x and then less than 2. So here we can draw the interval of convergence. So 1 at negative 2, 1 at 2, and then we cannot guarantee the 2 endpoints converge, so that's why we have to use an open circle. So this is negative 2x and then 2, so that is the interval of convergence. And then outside of this interval, the power series is diverse. So this is the interval of convergence. And then the radius of convergence, you have a 0 in the middle, right? So the radius is equals to 2. You can either write this, or you write negative 2 comma 2 in both in parentheses. How do you prove that the power series is convergent at x equals to 2 or negative 2, then you have to tell me what happened when x is equals to negative 2 and what happened when x is equals to 2. You have to plug that into the power series and then to determine if the series is convergent or divergent. And then regarding this technique, we discussed tons of example in the previous lesson. This part, I will leave this part to you. So that would be the end of this video. If you think my instruction is helpful, which is, let me know in the comment section below. Like the video for me, subscribe to my channel, please. That only takes you 5 seconds to do so. I will see you all in the next lesson. Signing off for now.